Hey tech enthusiasts, buckle up. Today we're diving into a potential earthquake shaking the very foundation of the AI chip market. We all know Nvidia has been the undisputed king, but a new challenger is emerging, fueled by something called inference. Is this just a minor tremor, or the start of a major shift that could redefine the entire landscape? Get ready, because the answer might surprise you, and it could impact your investments, your career, and even the future of AI itself. Did you ever think that Nvidia could actually be threatened? Well, think again. The Financial Times just dropped a bombshell, reporting that Nvidia's competitors are aggressively targeting the inference market. What exactly is inference? Think of it as the using part of AI. Training an AI model is like teaching a dog new tricks. Inference is when you actually tell the dog to sit, stay, or fetch. DeepSeeks are one model, for example, and other reasoning models require a huge amount of computing power when a user makes a request. This is inference in action. And until recently, the focus was all on training. But now, as AI becomes more widespread, inference is expected to become the dominant need. This is where companies like Google, Amazon, Microsoft, and Meta smell blood in the water. They're not just sitting on the sidelines. They're actively developing their own chips and platforms to compete directly with Nvidia in this crucial area. Let's really break down this training versus inference dynamic. Training requires massive parallel processing power to crunch through mountains of data and adjust the AI model's parameters. It's a one-time, albeit resource-intensive, event. Inference, on the other hand, is continuous. Every time a user interacts with an AI chatbot, every time an AI analyzes an image, every time an AI makes a prediction, that's inference. And with the explosion of AI applications, the demand for inference is growing exponentially. Think about it. Every search query powered by a large language model, every AI-driven recommendation on your favorite streaming service, every fraud detection algorithm running in the background, it all relies on inference. Therefore, inference is the new battleground. So why has Nvidia been so dominant in the first place? It's a combination of factors. First, they had a head start. They recognized the potential of GPUs for AI acceleration early on and invested heavily in developing the necessary hardware and software. Second, they built a strong ecosystem. Their CUDA platform became the de facto standard for AI development, making it difficult for developers to switch to alternative solutions. Third, they executed flawlessly. They consistently delivered high-performance chips that met the evolving needs of the AI community. It's like they were playing chess while everyone else was playing checkers. But now, the rules of the game are changing and the competitors are playing chess too. Now, here's where it gets really interesting. While Nvidia excels at general-purpose GPU computing, its competitors are focusing on application-specific integrated circuits, or ASICs. These chips are custom-designed for specific AI workloads, like inference. This allows them to achieve significantly higher performance and energy efficiency compared to general-purpose GPUs. Think of it like this. Nvidia's GPUs are like Swiss Army knives, capable of doing many things reasonably well. ASICs are like specialized scalpels, incredibly precise and efficient for a specific task. Google's TPUs are a prime example, as well as Amazon's Inferentia and Trainium chips. They are specifically designed for inference and training workloads within their respective cloud platforms. Let's zoom in on Google's Tensor Processing Units, or TPUs. These chips are specifically designed for machine learning workloads, and they've been deployed internally at Google for years, powering everything from search to translation. Because of Google's massive scale, they have a huge amount of real-world inference data, which allows them to fine-tune their TPUs for optimal performance. The TPU advantage is not just about hardware, it's also about software. Google has built a comprehensive software stack around TPUs, making it easier for developers to deploy AI models on their infrastructure. This creates a powerful ecosystem that rivals Nvidia's CUDA platform. A paper published by researchers at Google, cite a relevant TPU paper, showed significant performance gains compared to traditional GPUs for specific inference tasks. Adding fuel to the fire, Nvidia-backed CoreWeave is preparing for its IPO, valued at a staggering $35 billion. They've even agreed to acquire Weights and Biases for $1.7 billion, a major player in the MLOps space. This strategic move is all about accelerating the development and deployment of AI applications. CoreWeave's revenues exploded by 737% in 2024, reaching $1.92 billion. However, a significant portion of their revenue comes from Microsoft, making them vulnerable to MSFT's moves. This highlights the intense competition and the high stakes involved in the AI infrastructure market. It shows that even companies closely tied to Nvidia are facing challenges and opportunities in this rapidly evolving landscape. And don't count out Amazon. Top analysts predict a massive revenue boom for Amazon Web Services, AWS, due to its investment in generative AI. One analyst estimates that AWS Gen AI revenue will skyrocket from $2.8 billion in 2024 to a mind-blowing $56.3 billion in 2030. This growth is largely attributed to Amazon's partnership with Anthropic, the AI company behind the Claude AI service. Amazon is a minority investor in Anthropic, and AWS is their official cloud provider. The potential revenue from Anthropic could reach billions of dollars by 2027. This is a huge vote of confidence in the future of generative AI and the crucial role that Inference will play in its success. There's another crucial factor at play here: open source. The rise of open source AI models and frameworks is democratizing access to AI technology. This makes it easier for companies to build their own custom AI solutions without relying on proprietary platforms like Nvidia's CUDA. Frameworks like TensorFlow and PyTorch are becoming increasingly popular, and they support a wide range of hardware platforms, including ASICs. This gives companies more flexibility and control over their AI deployments, further reducing their dependence on Nvidia. It's like the difference between buying a pre-built computer versus building your own. Open source is the equivalent of building your own and customizing it to your specific needs. Now, before we write Nvidia's obituary, let's consider the counterargument. Nvidia is not standing still. They are actively developing new technologies to address the challenges of inference. They are also leveraging their existing ecosystem and customer relationships to maintain their market share. It's important to remember that Nvidia has a proven track record of innovation and adaptation. They've overcome numerous challenges in the past, and they are likely to do so again. They are not just a hardware company. They are a platform company, offering a comprehensive suite of tools and services for AI developers. This gives them a significant advantage over their competitors. They are also aggressively investing in new areas, such as networking and data center infrastructure, to further solidify their position in the AI market. So what's the verdict? Is Nvidia doomed? Absolutely not. But they are facing a serious challenge. The rise of inference is creating a new opportunity for competitors to gain market share. Nvidia needs to adapt quickly and effectively to maintain its dominance. They need to embrace new technologies, such as ASICs, and they need to continue to innovate in both hardware and software. The future of AI chips is uncertain, but one thing is clear: the competition is heating up, and the next few years will be critical. It's like watching a heavyweight boxing match. Nvidia is the reigning champion, but the challengers are hungry, and they're coming in swinging. Ultimately, the future of AI chips will likely be a hybrid approach. We'll see a mix of general-purpose GPUs and specialized ASICs, each optimized for different workloads. Nvidia will likely remain a major player, but they will face increasing competition from Google, Amazon, Microsoft, and other companies. The winners will be those who can deliver the best performance, energy efficiency, and cost-effectiveness for specific AI applications. So what does this mean for you? Whether you're an investor, a developer, or just someone interested in the future of technology, it's important to stay informed about these trends. Keep an eye on the developments in AI chips, and be prepared for a period of rapid innovation and change. And don't forget to leave your thoughts and predictions in the comments below. What do you think? Will Nvidia maintain its dominance, or will a new player rise to power? Let me know what you think.